HVAC design requires piecing together lots of contextual data to produce actionable information, and that has been our focus in this chapter. First, we geolocated the building and then we chose the correct weather station for the facility. Then we linked in the architectural building geometry and even created the conceptual mass for the facility. Then we acquired the coordinates from the linked architectural model through the acquire coordinates tool. Also, we created the mechanical spaces in the facility and assigned them their correct space types. Also, we configured the energy settings, which includes information such as the building type, services and HVAC information, and also such things as the construction types for the various building surfaces and many other assumptions that inform the energy analytical model. We also defined the zones and created their respective zone equipment and the facilities overall HVAC concept design. Then we created the abstract form of the spaces and surfaces in the facility through the energy analytical model. And finally, we ran a simulation to generate a report that's based on the combined contextual data. So in this video, we'll examine the report aiming to explore areas of improvement through a comparative analysis and ultimately proceeding to detailed design more informed about the facility and its HVAC requirements. So open the model you used in the previous video or analysis report in the chapter 1 exercise files folder. So at this point, launch Revit, navigate to the exercise files. From the chapter 1 folder, open this file, analysis report, which I have here. Then open the analysis report generated in the previous video from the project browser. Now, if there's a message about a missing report file, you can go to the Analyze ribbon from the Energy Settings dialog, map the reports folder path to the exercise files folder, or you can simply run the analysis. Now, from the Properties browser, you can see that the report style is loads. You can switch to detailed, but we'll get to that shortly. So the loads report style has 3 sections, which are the zone load summary, system load summary, and design psychrometrics. And you can also choose your reports unit or print it to PDF from the top right corner here. So on the zone load summary tab, you can select a zone to examine its cooling and heating loads. So this tab focuses on zone equipment. And from here, you will see the load contributions from the building envelope, the internal gains, the systems, as well as the total loads needed for equipment sizing. So from here, you can see the total loads that you need to size the various equipment for the various zones. So this is for cooling and this is for heating. And then on the left side here, you see a subsection showing the environmental conditions at peak. This is for cooling, this is for heating. And then there are other high-level metrics for QA/QC purposes as well that you find under this tab, which is the zone load summary. Then the system load summary tab is similar to the zone load summary, but focuses on air systems. Typically, it contains information about the air temperature at various points in the system and the primary fan airflow and ventilation flow. So currently it's blank because this project has no air handling units or air systems in system speak. Then you have the design psychrometrics tab, which shows the psychrometric state points of air for any system that contains a cooling coil. So the focus here is the cooling coils within the systems. So this is where you can use to size them. So there are 3 sections here. You have the psychrometric chart showing the state points, the state of the air at each point of a system. Then you have the summary table by the left, which highlights the system properties. And then below you find a table that shows the specific values for psychrometric state points at constant pressure. So this is similar to what you see on the charts. For example, you can see the various coils entering, leaving, outdoor, and whatnot. The same thing you find on the table. So this is a more detailed breakdown of the charts, and of course this is for a particular zone. You can always switch to a different zone and this will update. So besides the loads report style, you can view the reports in the detailed format, and this might look different depending on the simulation type. Remember that what we ran is the load sizing report. So for this particular simulation, many of the initial sections here have 0 values, and that is because this report does not focus on the facility's annual energy use. But when you scroll down here, you will see the table of contents. So the table of content provides a quick access to the various sections of the report. So I'll just quickly run through some of the important ones. The first one I want to look at is the component sizing summary. So this shows the design size, maximum supply air, outdoor airflow rates, and hot and cold water flow for each zone in the facility. So you can see how this has been broken down for all the zones. And then also you find information about the chilled and low pressure hot water loops in this particular section. So you can see coil cooling water and coil heating water. So this just basically provides a detailed breakdown of the component sizes and their summary. Then another section I want to quickly look at is the equipment summary. So when I go back to the table of contents here, I switch to equipment summary, and this gives a breakdown of all the equipment in the facility. So you can see the central plant, the cooling coils, direct expansion cooling coils, heating coils. So this provides you with all the equipment, the summary of all the equipment in the facility, which is good for sizing. And interestingly, we've not modeled anything in this project and we're able to generate this detailed information. Another good important section is the HVAC sizing summary. So when you go here, you see the HVAC sizing summary, and this provides such information as the sensible heating and cooling loads for coil sizing per zone. So you can see the zone sensible cooling, and you can see the zone sensible heating. So these are all very detailed information. You can also might also be interested in the outdoor air summary for the facility. So there's also a section for that. So when you go to table of contents here, you will see the outdoor air summary, and this provides such information as the average and the minimum outdoor air during occupied hours for the facility. So there are just so many sections in these detailed reports, and the detailed reports type contains extensive information, and you can share it with even external parties. To do that, simply right click anywhere here and you can print the report to PDF. But it's important to mention that the unit in the report is based on the length unit in your project, either metric or imperial. Now, beyond the report, this analysis computes the peak heating, cooling, and latent cooling loads for each analytical space in the building. So when you select an analytical space from the system browser, you can also view this from the 3D view or even from the schedule. When you select an analytical space from the properties browser here, you can see the computed airflow per area under mechanical flow, and then under energy analysis you can see the peak heating load, peak cooling load, and peak latent cooling. These are all computed with this analysis. Now, the primary advantage of this report is leveraging the insight on loads to size the project's equipment before modeling anything. So it's likely that you will tweak some of your earlier assumptions, run new simulations, and compare the results. Let's say, for example, you want to compare between two different systems. I can choose to change this my zone equipment from, say, 4 pipe fan coil to say VRF fan coil, for example. Of course, you need to configure some other different things for that to work, because you can see that this gives you an error. But these are some things you can compare and contrast which one has more energy savings for this particular facility. You can also change other things such as the construction. So I can go to the energy settings and change the schematic types or the analytic constructions, and then I use that to generate a new system analysis and compare the results. You can also change the outdoor air information for the spaces and even for the entire facility. So for example, I can go to the floor plan and pick my space, the mechanical space in this case. Then I go to the space type and I can change some of this information here, such as the outdoor air information and whatnot, even the cooling and heating set point and all that. Or I can also go to the energy settings and change the outdoor air information and all that from here. You can even switch the building services, the HVAC information and all that, and compare which of them have more savings for that particular facility. So at the end of the day, system analysis is an agile approach to designing HVAC systems before committing to modeling physical system. So all the simulations will be saved as separate files, and you can access them from the project browser for easy comparison. So whenever you run a new analysis, at the time you go to the project browser here, you see it as a separate report, and you can always compare between the reports to see which one has more energy savings for your project. So as a mechanical engineer or energy design specialist, the videos in this chapter are critical to designing sustainable HVAC systems in your project. So now you can run and review system analysis in Revit.